Hi there, welcome to the It's All Good Mining and Repair channel. I'm Brian. I hope you're having a great day. And today I'm kind of filled with some real good energy. Maybe it's because Bitcoin went up over 26,000 earlier today. That always makes mining nice. But maybe it's because this board right here, which I call 001, this board right here, which I thought I fixed a long time ago, and then it died with stupid temperature sense errors. I finally, I think I'm making some progress. So let me show you what I've got. What do I have on my screen right now? Let's dig into it. So I decided instead of trying this board out in Vanish 2.0.4 firmware, I thought I would stick it in a different miner chassis and load it up with the Hiveon software. I don't use Hiveon for ASIC mining. Yeah, it's nice to have the unified, center like I do with all my GPU miners, but I just don't care for it. I don't like the settings or the features that it has as far as tuning goes. But I do like this for diagnostics. So if you're diagnosing hash boards and you need a different point of view, check this one out. So what I've got here, you see this normally in Vanish. Vanish has a very similar thing where you'll see how each chip is performing. I let this thing auto tune, and what we've got right here right now is 475 megahertz. And you'll see that chips 18 and 44 are really problematic. There are other chips that are problematic, like chip 4 has been really weak. Chip 14 is really weak. The domains where you've got, let's see, 26 through 30, as well as 46 through 50, those at different frequencies would go all red. So what I'm going to do is I'm going to get into my spreadsheet that I made. I'll show you what I'm talking about there. Okay, so what we're looking at here is my spreadsheet where I did all, where did my mouse go? Oh, there we go. So each one of these is like 500 megahertz, then it tuned down and went 495. It tried 490. And so I just recorded every single chip that went 0 at that frequency, or if it was yellow, like it was 60% of ideal. So what I started seeing when I did that, now I kind of missed some of the numbers on 500, but then by the time I got to 495, I was like, oh, I need to start tracking more of this. So what I started seeing are some interesting consistencies in things that are constantly bad, like chip 14 is constantly bad. Chip 4, it's bad. Chip 18, there's something really wrong with chip 18 here. I wonder if chip 18 maybe is missing a resistor, because it's always bad. It's always bad. Same thing with chip 44. It's always bad. Now 46 through 50, there we go. 46 through 50, it goes to 0 on several of the different frequencies. And even then, for on 470, it was very weak. So, and then last but not least, chip 62 is constantly less than ideal. So what I'm going to do this first round, I'm going to jump in. I'm going to take out. I'm going to replace 62. I'm going to replace 44, and I'm going to replace 18, and I'm going to replace 14 and 4, because those were chips that were always bad in the tuning. So I'm going to take those chips out. I'll put it back in the Hiveon loaded miner, and I'll run it again, and we'll see what happens. And hopefully, after I do that, I straighten out these weak chips. Hopefully I can put it back into my Vanish loaded miner, and I won't have any temperature sense problems. So let's get into it. All right, we're back. Okay, so first things first, go ahead and take it off now. How many chips did I say I was going to replace? Like 6 of them? I'll probably go ahead and give this thing an alcohol bath, just because. So let me go ahead and dive into this, and I'll speed the video up because you don't need to see me taking it apart all the time. Okay, so just like that, we have everything cleaned up and ready to go. So yes, I do need to change or to filter out all the debris in my alcohol solution. So what I'm going to do now is I'm going to mark the chips that I need to pull, and I'm just going to put a big 0 on them. Remember, for anybody who is new to this, on the S17 Plus, the signal comes in this way, or with the exception of RO. Okay, all the other signals, RO flows backwards, but everything else, you see it come in on the traces. The traces are actually right here along the edge of the board, right? So this is the input of the traces. They turn down. This is chip 1. Chip 1, chip 5, chip 6, 10, 15, 20, 25, 30, 35, 40. You just follow the traces and you get all the way over here to 65. So let's see. What were the numbers? I'm going to ignore, what did I say? So 30, so that's 10, 20, 30. So this whole bank right here would go 0 from time to time. But I think, I have a suspicion that it's actually because of some other chips. So this is 20 right here. This is 18 right here. That's causing, so that's a weak signal chip. 4 is also problematic. Now, 4 used to be called OK, but we're going to make a big 0 there. And let's see, what is the other one? 14 I'm going to take out. So 10, 15, 14. There's 14. Let's see, what other? Let me check my sheet. 44. Okay. So we go 10, 20, 30, 40, 41, 42, 43, 44. Okay, and then the other really problematic one was 62. So 62 is right there. 1, 2, 3, 4, 5. Right? 5 chips that we're going to get rid of. Okay, so this spreadsheet here is very helpful to me, and I keep updating it. I've got most of the resistors all marked out, but as I get stuff that's not necessarily directly connected to a board, to a chip, I find those values. I look them up in the manual, or I'll put them on my LCR meter and get them that way. But I want to go look at U72, which that's chip 44. There we go. So now let's go. So there's three spots that we should not have resistors. Only 3 spots should be missing. 761, 777, and 785. Okay. So let me pull my microscope over there, and let's flip over to the microscope. So what I said was that 761 does not need a resistor. Okay, so 761, let me get my pointer here. 761 is this one. 777 doesn't need a resistor. And 785 didn't need a resistor. Okay, cool. actually, where I found there to be resistor problems is actually on this side of the chip right here. What I'm going to call kind of the input side of the chip, because this is where the addressing of the chip happens. Let me pull that up and I'll show you what I'm talking about. So if you notice there on the left-hand side, actually it doesn't matter which one. If you look at mode 0 or mode 1, if you'll notice pins 4, 5, and 6 are used to set the address, and typically that's done with resistors. So if a resistor is missing, that could be a problem. All right, let's get out of my chip display there, and let me move over to the other one, which is right there, U33. So let's go back here to U30. Let's go back to the spreadsheet. Go back, there we go, boom, U33. So 421, 440, and 467 are the only ones that should not have resistors. Let's check and see how that works. So where is 421? Oh, 421 is easy to find. 421 is right, it's the top one here. 440 is this one. So the left one is 421, the right one is 440. Okay, and then the other one that should have a missing resistor is 467. That's right here. Okay, it's good. So this is good. This is good. Let's look at the other side. Here we go. We've got everything's got a resistor there. Good. Okay, so here's what I'm talking about. 4, 5, and 6. Those 3 pins are the ones that you apply resistors to them. And that's how the address of the chip gets set. Now, the interesting thing, one of these days I hope to get a better boom. Okay, well, I was going to say we don't have good solder there, but it looks like we do. Those are the chips we're going to replace. Good news there is it doesn't look like we have a resistor problem or an addressing problem, right? So we know the board works. Just as a reference, though, I do want to go ahead and put the board on the tester. I always like to do that right before let's go here, right before I start working on the board. I just want to make sure that I haven't introduced a problem. This way I kind of have like a way to go back to. Cool. All right, 65 chips. That's exactly what we expected. Let's dive into this. Okay. Turn the air off. Get my hot air ready to go. Cool. All right. 425 is the temperature and 80 on the airspeed. The max on this unit is 120, so it's not 80%. Just FYI, I'm trying to save you the headache of something I learned. All right, looks good in my microscope. How does it look in your microscope? Looks a little crooked. Okay, but otherwise it's good. All right. Here we go. So just a point of reference, when I pull a chip like I just did, if that chip is identified as weak or problematic, once I put it into a miner like this, I don't recycle that chip. That chip goes straight to the trash because currently I don't have any way to test for weak chips like that. So if I get a weak chip and I pull it off the board, it goes to the trash. It doesn't go back into the recycle pile. Just something useful to know, right? All right, just a quick public service announcement, if you will. When you're desoldering these little bitty pads, remember not to put much pressure on them, because if you put very much pressure on these little bitty pads, you'll damage the solder mask. And I mean, if you like doing solder mask repair, press as hard as you want, but really the heat does all the work. You don't need to pull that hard. Now, when you're doing the larger pads here, you can put a little bit more pressure, but again, remember, if you're pushing up against this solder mask bridge right here, you can do damage to it. So, a light bit of pressure with your iron is really all you need when you're doing this. Let the heat do the work. Okay, well, so what I did there is I spun the board around, and I'm going to work on the other side now. So I'm going to replace chip 4 now. Let's get to it. Okay, so I always love doing the ones on the edge, right? Because those are just easier ones to get to heat-wise. Just so I can keep track. There we go. I'm going to put a little blue dot on there so I can keep up with which ones I replaced today. All right, I'll go ahead and I'll do 44 next. Okay, so I dropped that one in from upside down, from, I guess, from the top of the board. So it was upside down to me, and that made things a little bit more challenging. That's why you saw the drop didn't happen just perfectly straight. All right, so just letting that cool down a little bit, because this part of the board right here is nice and toasty. Okay, so that's 3 chips done. We got, looks like 2 more chips to go. Setting it up. All right, there we go. Let me set the microscope. Okay, so you may have noticed that these solder balls that came about this time. So that's because of all the I put a little bit too much solder on the positive pad and trying to get those solder balls off. Now there we go. Put too much solder on the the top solder pad that was right underneath here, and so I knew when I put the chip down there, it didn't want to really go all the way down. It made great BBs real quick on the sides. That was good, but I knew I needed to kind of push on it a little bit more to get it to really seat. So you may have noticed me doing that. Otherwise, we're good to go. We got one more to go. I'm going to let this one cool off for just a little bit. Okay, so this has got a red dot on it. This is chip 8. Let's see, 16, 17, 18. Yeah, this is chip 18, which was one of the chips that always gave a 0 reading, no matter what the frequency was. So let me take this chip off, and this will be the last of them. Okay, there we go. So that was it. 5 chips. Took them out. Some of the chips you may have noticed in the soldering, I would desolder, and others I just put a little flux on there and I cleaned them up. Those were ones that I had previously pulled. So if I had already pulled the chip and I could recognize it, because usually it was a cleaner solder job in those cases, just refresh the solder and then keep moving. There's no reason to strip the solder every single time as long as it's not unleaded solder. Unleaded solder you always want to take off before you put leaded on. Okay, here we go. Let's find out if it's going to work. Put it in tester mode. Yeah, buddy, got the fan on. Nice and high. No pressure. No pressure. Boom! All right. So it's not good yet. We put the temperature tester on there. Bing, bing, bing. I got 4 temperature sensors. That is really, really good. So give me a second and let me go clean the. You guys really don't want to watch me clean this, right? No. So give me a second to clean this up, and I'll be right back. How about that? All green. We're running 525 megahertz on the board. And yeah, there's that one right up there. What the hell? Well, probably some of you who know how to count realize that I actually changed out chip 63, not 62. So if I don't have any other problems, I won't worry about it. I mean, it's not perfect, but it's good enough, right? It's working. Everything's green. So that's fantastic news. Let me get it into the Vanish miner, and let's see how it works there. Because this is great, but I don't run this all the time. I run Vanish. I just use this now as a diagnostic. All right, so here's the results of the Vanish test. take a look up there where it says temp chip, right? 73, 73, 76, 89. That's 13 degrees higher than chip number 3. And worse, it's 16 degrees higher than chip number 2. Chip number 2 and temp sense 2 and 4 are on the same side of the board. So what's going on there is most likely chip 55 is one of those chips that if we were to test it with the amp draw, we would see that it's pulling a lot more current than it should. So even though it's a green chip in the hash little diagram, I'm going to go ahead and pull that. And while I'm at it, since I need to pull 55, I'm going to actually replace the real chip 62. All right, so quick disassembly. And before I get started on this, I just wanted to point something out. So I only have 2 chips to replace, right? I have this one here and I have this one here. So since they're on the edges, I took a Q-tip and I just went in. I cleaned up the sides and the top like that. I didn't even use any alcohol. Now I will have to, when I'm desoldering these, I'll probably have to use some alcohol there, but it's just, there's no reason to go through the full board cleaning for this. So there you go. That's just saving a little bit of time. Right. So yeah, I'm a big fan of always testing. Like every time I get through a phase. So like I've replaced chips. Now I want to test because it doesn't cost me anything extra to hit the test button. So here we go. Let's just hit it. I don't have to pay per test. Thank goodness. All right, load it up. Boom, 65 chips. That's good. Flip over to the temperature sensor. Loading it up. Good. Okay. Now chip 55, temp sense 4, is running a little bit hotter than the others by like a couple of degrees, but that's also the chip I just replaced. So the fact that it's about 4 to 5 degrees higher, probably at this point is okay. Let me just let this sit there for a second. I want to see what happens, right? Between chips 2 or temp 2 and temp 4 across the bottom. So between 15 and 55, what are we doing? Okay, see, they're kind of staying together now. 46 and 55. Okay, good. Now they're staying like they should be. So that's probably what was wrong with that. All right, let me get this back together and we'll test one more time. And then we'll get it back into the Vanish miner. All right, just like any other time, once I reassembled, everything's there. I want to test it one more time, right? Actually, oops. Okay. 65 chips. Good, good, good. Uh-oh. Do we have a weak chip? Well, we've already got it back together, so let's see what we get on the tester, or with the temperature sensor. Good, 34 to 36 degrees on the temps. Okay, I like that. 2 is now was hotter than 4, so very good. All right, let me get this back into the miner with the Vanish firmware on there, and let me find out what it's doing. Be right back. All right, so after the resolder and everything, what do I know? Well, running it in the Vanish software, I still have a temperature issue. Okay, it's still running hot, but it's not running out of control. The fact that I replaced the chip and it's still doing the same thing tells me it could probably be something to do with the heatsink, because I see this on the other board as well that's running that same kind of heatsink. So maybe time to take a hacksaw to the heatsink. But let me show you what else I've got. Look at that. This is in the Vanish firmware. Okay. Look at that. That's beautiful. Everything is green. Everything is working in the ideal range at 500 megahertz. Except for the first chip. It's a little low. No big deal. If I get, I'll watch that chip over time and see how it goes. So right now that means, if you're keeping score, we have fixed board 001 and board 002. Check the playlist. I do a playlist for every single board. And both of these boards now I have put them into an Antminer, and they are currently hashing on Pega. If you haven't tried Pega already, there's a link down below. Yes, it is an affiliate link, but you're not going to pay any extra fees mining at Pega if you click on my link versus anybody else's link. Come over and try Pega. I'm enjoying the heck out of it. They had a problem the other day where it was just a payout problem, but it wasn't a problem with the tracking, and they notified me. That was just nice. I like that kind of service and support, and their fees are lower. I want to do one other public service announcement real quick. So there we go. You might find these 3D printed stands on eBay. This one was sent to me as part of a package with a fan spacer. I'm not going to tell you who it is. I'm not going to tell you the seller on eBay. But if you see these, don't waste your money. They're poorly 3D printed, and I mean they're just this one is almost broken. The other one I have is already broken. It just broke off. So avoid these. Okay. If you want to make your Antminer more stable, and because maybe you only have one hash board in it, you can actually flip the Antminer upside down. I've got a picture right up there that shows how I did it. But yeah, you can just flip it upside down. It runs fine, and it's very stable on a wire rack. All right, well that does it for now. If you've made it this far, be sure to hit the like button, and don't forget to subscribe and smash that notification bell. Thanks so much for watching, and to quote one of my favorite YouTubers, I hope you learned something today.